Introducing the new composite tube optimizer for MultiMech. In this video, we'll go through the process on how to evaluate the burst pressure of your tube and to optimize the tube performance. First, you create your microstructure. Here, you input your fiber volume fraction, pick your liner material, your composite fiber material, and your composite resin. From there, you select your pressure, your radius, your liner thickness, composite thickness, number of plies, and layup angles. This is for evaluating a burst pressure of a single tube. MultiMech will automatically build your tube, and then it will apply the internal pressure, and it will evaluate the burst pressure of the tube. You can see here that the calculation is done, and it automatically brings the post-processed view of the tube. Here we have a toolbar that can change the different stress and strains you can view within the tube. You can move the object around in 3D space to help you view different components of the tube. You can see that with the 0, 90, 0, 0, 90, 0 layup, we have stress concentrations in the 90-degree layup, which makes sense. We can evaluate all the different stresses very easily within this tube. And also the stiffness of the different elements. You can see here that we have the C1111 constitutive tensor. You can change the scale bar to focus in on different regions, and you can reduce the range for where you want to view the stiffnesses. The next capability is to optimize the tube. From here, you can set a goal in which you have a target pressure, and then you have an excess pressure that you can allow to go over. From here, you can put certain limitations like radius or max internal radius, and then also the number of plies, liner thickness, and composite thickness. These can all be changed and customized throughout MultiMech. After listing the max number of iterations that the optimizer will run, it'll start running different iterations, and using a genetic algorithm, will test different tubes for the burst pressures to find an optimized tube layup. After every iteration, the results will be shown on the screen. Here you can post-process it just like you did with any other tube that we saw earlier. Every single time it finds a new best tube, it'll list it down as the best tube, identify the ID and its burst pressure and its layup angles. The last capability is defect insertion. You can pick any of the last tubes that were run in the optimization. You can pick a minimum percentage defects and a max percentage defects and a number of subdivision for those different defects. You can also pick the type of defect, whether that's a void, resin pocket, or a custom defect, then list the number of samples you want for each percentage of defects. After it runs the defect analysis, you can go to the plot. You can see how the burst pressure changes for the different percentage defects and for the different random distribution of defects within that tube. You can see how there's a range for each percentage of defects. After this, all the results files will be available, so you can look at the reaction forces within the model